All right, in this video we're going to talk about where the energy for muscle contraction comes from. And there's two basic places that the muscles get energy from. One is creatine phosphate and the other is cellular respiration. So as you can see in this diagram, there's kind of this cycle that happens within the muscle cell. And since muscles use a lot of energy, they need a source of stored energy that they can quickly access. So when cells do cellular respiration in the mitochondria, they get energy in the form of ATP. And that ATP can be used for muscle contraction. Now, anytime the amount of ATP in the cell is high, the muscle cell is going to take some of that and create creatine phosphate. And that's a stored source of energy that can be quickly converted into ATP when the ATP levels are low. So when ATP levels are low, the creatine phosphate is going to be broken down and the phosphate is going to be used to create more ATP that the cell can use for muscle contraction. So like I said, creatine phosphate stores energy that can be quickly converted into ATP that the cell then can use for muscle contraction. So oxygen plays a big role in determining how much ATP is produced in a cell from glucose. So in order to get the most ATP out of glucose, we need oxygen to do the full steps of cellular respiration. So one thing that muscle cells have that other cells don't have, they have a way to store oxygen. And that is in the form of a protein called myoglobin, which is similar to hemoglobin that carries the oxygen in the blood. So when oxygen levels in this cell start to drop, the myoglobin can release oxygen and the cell can continue to do aerobic respiration for a little bit longer. So the first stage of cell respiration can happen whether oxygens are available or not. So we call this the anaerobic phase, and it's glycolysis. It happens in the cytoplasm. In the process, glucose is converted into pyruvic acid, and there's a net gain of 2 ATPs. If oxygen is available, that pyruvate can move on to the next step, and we call these steps the aerobic phase. So pyruvate moves into the mitochondria, goes into the citric acid cycle, where 2 more ATP are produced. And then in the process of doing this, there's some electron carriers that are produced both in glycolysis and in the citric acid cycle that are used in the electron transport chain. And this is where the oxygen is used. And in this case, 32 ATP can be produced from the electron transport chain. Now, if oxygen is not available, then the cell can use the myoglobin to release some of that extra oxygen. So if oxygen is available and we do all 3 steps, we get a maximum yield of about 36 ATP. Now, when oxygen is not available, the cell only does glycolysis, and then that pyruvate is converted into lactic acid. Now, that lactic acid is a toxin, and so we have to get rid of it. So what happens when cells don't have enough oxygen, when muscle cells don't have enough oxygen, they go into what's called oxygen debt. And a debt is something you have to pay back. So the amount of oxygen needed by a liver cell to get rid of the lactic acid, to restore the glucose levels, restore the ATP, the creatine phosphate levels, back to what they were like before the muscle went into oxygen debt. So that's what oxygen debt is. So in order for glycolysis to continue, the cell does lactic acid fermentation. In this case, pyruvate is converted into lactic acid. The liver can convert lactic acid back into glucose, but that takes oxygen. So there's a point where the cell has to switch from aerobic to anaerobic respiration. That's called the anaerobic threshold or the lactic acid threshold. So this is the activity level where there's not enough oxygen going to be available to continue to operate at that activity level. So lactic acid also causes muscle fatigue. Muscle fatigue is defined as the inability to contract after persistent prolonged use of the muscle. So common causes: decreased blood flow, an ion imbalance across the membrane of the muscle cell, the sarcolemma. The most common cause, though, is lactic acid building up. And then there's simply the fact that you just don't want to continue that exercise anymore, psychological reason. So lactic acid also causes delayed muscle onset soreness, where you're sore the next day after exercising. Now, sometimes, usually because of an ion imbalance, you can get a cramp, which is a sustained, painful, involuntary muscle contraction. Usually it's potassium levels that are low that causes cramping. Now, one side effect of muscle activity is it produces heat. Heat is also a byproduct of cellular respiration. So most of the time, the environment that we're in is not as warm as we want to maintain our body temperature. So the major source of heat to keep our body warm is our muscle cells. So the heat from the muscles is transported through the body through the blood. The blood's going to carry that heat away from the muscle to other parts of the body that